All right, welcome back, students. Today we're going to be talking about cross sections. So, to understand cross sections, just imagine a plane slicing through a solid. Now, when we say solid, we're talking about three-dimensional shapes. Now, the intersection of this plane, a two-dimensional figure, and the solid is called a cross section. So essentially, what we're saying, you're taking a three-dimensional object, you're cutting it on some two-dimensional flat plane, and then the resulting shape, two-dimensional shape, is the cross section. So, for instance, in this first image, we see a cube that is being cut by this orangish brown kind of plane, and we see that it creates a square. Okay, so from cutting this cube, we got a square. Next, they do it along the diagonal. Now, because this one is going from corner to corner, this line is going to be a bit longer than the side lines, and that's why it's a rectangle. Finally, cutting here at the edge, notice they only intersected three different sides, which created a three-sided figure, so they created a triangle. Now, you can create cross sections from any three-dimensional figure. And different three-dimensional figures are going to give us some unique shapes. For instance, as we cut into a cone, a simple one being parallel to the base is going to give us a circle. However, if I rotate that, I can then get kind of a parabola or an oval or ellipse. Okay, now do it completely perpendicularly and I can get a triangle. From this rectangular pyramid, we can see we can get a rectangle. If I rotate it, now I can get a trapezoid. So this top one would be parallel to the bottom one, but we've got these different lengths. And so not quite a rectangle, but a trapezoid. Okay, and once again, I could find ways of rotating it so that, so I'm just at a corner and I can get different triangles. Okay, and this is going to be true for any of these shapes. There's going to be a whole lot of different shapes. Like this would just be qualified as a quadrilateral. Just no equal sides, nothing's parallel. It's just a quadrilateral. So there's some examples of different planes cutting through three-dimensional solids. So let's go through the notes now and figure some of these out. First, we see this hexagonal prism being cut. Looks like it's parallel to the base. And I can kind of see there in purple those six sides. So this is going to form a hexagon. Over here, it cut at three sides. And we got a triangle. Here, cutting into this cylinder, created four sides perpendicular to the ground. So we're going to create these 90 degrees. So this is just a rectangle. This cone looks like this is parallel to the ground as well. So this is going to just form a circle. A sphere, interesting thing about spheres, any which way you cut them, you're going to create a circle, so long as you're cutting it with a flat plane. Okay, next We do see 4 sides. I see that this side is going to be kind of parallel to this side. So we could qualify this as a trapezoid. All right, so let's move on. Let's talk about drawing one yourself. So this asks us to draw the cross-section formed by the plane parallel to the base that's going to intersect the red line that's already on the pyramid. So keyword here, parallel to the base. What is the shape of the cross-section? So if I'm going parallel to the base, my base is all of that. So I want to make sure that all the lines I draw, so on this side, I want it parallel to that base part. So I'm going to have it right there. And actually, let's go ahead and continue the red. So for this next side, once again, make sure I'm just drawing parallel to the base that was already drawn there. Same thing, parallel to the base that was already drawn there. And there we go. There's my cross section parallel to the base. And what is the shape of that? Let's see. Square. So because this was a square pyramid and we're parallel to it, it's going to be smaller than the base square, but it's still going to be a square. All right. So let's look at a problem involving cross sections. So a machine at a sawmill cuts a 4-inch by 4-inch piece of wood lengthwise along its diagonal. So look right there, we're cutting along the diagonal right there. Find the perimeter and area of the cross section formed by the cut. All right. So perimeter and area is not too bad, but we need to figure out what shape this is going to be. Well, this is going to form a rectangle. Now, we know some of the dimensions of it. We know how long it is, 8.5 feet long. But what about this diagonal length? I know that this is 4 inches by 4 inches, but I don't know the diagonal. So before we even begin, I need to figure out that length. And because we've got a triangle here, essentially, I can figure out the length of the diagonal by finding the hypotenuse. So we're going to have, all right, there we go. So we're going to have a squared plus b squared is equal to c squared. And our two sides were 4 and 4. So we got 16 plus 16. So 32, which is then going to be square root 32. So in order to get rid of the c squared, the inverse of a squared is a square root. So we're going to have c is equal to square root 32, which we can then simplify into a 4 square root 2. Okay, so now I know the length of that diagonal. So my rectangle is going to be a 4 square root 2, 2 by 8.5. All right, so finding the area. Area is just multiplying the length times the width, which in this case is 4 square root 2 times by 8.5. So that's going to be a 34 square root 2. All right, so there's our length or our area. Perimeter can be done by 2 times the length plus 2 times the width. For us, that's going to be 2 times 4 square root 2 plus 2 times 8.5. So we then get 8 square root 2 plus 17. Now, if we really want to, we can go ahead and approximate those. So I could type 34 square root 2 into a calculator, and we're going to get approximately 577. And let's see, we were in inches. So inches squared. For the perimeter, that's going to be about 215.31. Make sure I'm using my approximate, because we're not going to be able to write down all of those decimals. These go on forever. These are irrational numbers. So 215.31 inches. Okay. I hope this has helped you to understand cross sections a little bit better. Good luck.